Hello everyone, I'm honored to be part of the Collaboricom Academy Conference. The topic of my presentation is model-based evaluation and optimization of dependability for edge computing system. I come from China University of Petroleum, Beijing. My presentation includes those parts: introduction, dependability modeling and analysis of edge computing system, model and approach of dependability observation, experiment, and the last conclusion. Firstly, I'd like to introduce the background of my research. With the emergence of modern smart devices and wireless communication technologies, such as Internet of Things and 5G, the requirements for low latency have risen dramatically, which brings significant challenges to cloud computing. To take this challenge, edge computing is a novel computing paradigm have been proposed. However, best high-performance dependability is also one of the most important requirements, which is the degree of the stability to which a system can provide fault-free service without interruption. In order to guarantee the dependability of a computing system, its evaluation and optimization is a critical research problem. Secondly, I'd like to introduce the dependability model in our paper. During the operation of the system, there might be a series of problems, such as filter recovery and so on. In this paper, in addition to analysis of the type of filters, the correlation between filters with the system is also considered. That is, some filters will affect the system and lead to new filters before the recovery of the filter, which is called the correlation of filter. The system dependability model is shown in figure. In the real state, two filters divide the system. Whether the system has a state can be divided into integrity to ensure integrity maintained and integrity destroyed. We refer to integrity destroyed as ID. Integrity under the guarantee of accessible on behalf of all the components in the system, unknown state. But in the process of the system process, the request may be due to the filter of the network system, can't revise the user request. Unable to complete the user request, this state is defined as inaccessible. Refer to the failed state of large-scale service system. Hardware failure and software failure account for a larger proportion. Unsafe means that the failure may lead to catastrophic consequences. In order to analyze and quantify those attributes, consider CTMC for embedding the CTMC to calculate its transfer probability as equation. By solving a system of linear equations, steady-state probability embedded a discrete time Markov chain (DTMC) in each set. It's shown in equation. Assuming that the average waiting time of each set in the CTMC model is the same, the state-state probability of any state in the CTMC can be represented as equation. Therefore, the embedded DTMC steady-state probability and the original CTMC steady-state probability are equal. Availability represents the ability of the system to provide a working service to the user when a user needs it, and it expressed as equation integrity reflected, and the ability of the service computing system to resist an inappropriate system. Reliability is a probability that service can work continuously at a given time. Safety provides survives without consequence. consequence. It can be praised as follows. Maintainability describes the ability to repair and modify the system. This article considers that all faults can be repaired. So, the expression of safety and maintainability in the paper are the same. Thirdly, I would like to introduce the dependability modeling and analysis of edge computing system. The reward value of R stat and F stat are set to 1 and 0 respectively. The aggregation model is shown in figure. The rate transition RT is defined as a state transition from the ready state to the failed state, while the transition from the failed state to the ready state as a GT. The transition rate from the up to the down state is set as lambda is denoted as equation, and mu is similar. We can prove the steady-state probability of the aggregation model is equivalent to that of the original model. Edge computing and cloud computing cooperate, and the proposed model is shown in figure. We can draw four probability states of the survived system. The state A means that both of edge server and the cloud server can process the user requests normally. State AF means the cloud server can process user requests normally, but the edge server is faulty. And the state CF means that cloud server is faulty, but the edge server is normal. The state F represents both the edge server and the cloud server are faulty, and the system fails at this time. The CTMC transition rate matrix is represented by Q, as shown below. The steady-state probability in each state can be obtained using the following expression. Firstly, I would like to introduce the model and the approach of dependability optimization in our paper. In real service computing system, when tests are offloaded to the server, that the system can effectively process user requests. This issue is simulated as CTMDT problem through the state transition model. The policy mu is the set of all actions selected in every state. In order to maximize the expected average reward function G mu on the policy, the sum of future reward with an infinite horizon can be expressed as a formula. The G mu converges to a value denoted as any internal state I. A Markov process can be divided into embedded Markov chain and the soldering time of each set. Markov chain P mu satisfies the equation. The length of the time required by the set I can satisfy the exponential probability distribution. The CTMDP model will support the Poisson equation, where G mu is expressed as the performance potential function of state I. The performance potential G mu is the difference between the return and the long-term average return. The expression in the infinite time domain. In addition, For the CT-MDT model, the performance potential function can be expressed by the following. The per voice description provides that as a theoretical basis, the algorithm is shown as. In practical problems, due to the uncertain or larger scale of the state space, it's almost impossible to solve the question in question. The structure of the evaluation is evaluated through multiple sample paths, and the return value uses the TD method, which is a very effective method. Firstly, the word difference formula between the two strategies, named mu-E and mu-R. We use this to get the approximate solution of Jingyu, where Sk indicates the numbers of iterations. Then, the average reward value, eta mu, can be approximately expressed as the formula. Use G mu and the eta mu to get the algorithm for evaluation the performance potential function. In this paper, a larger high-performance service system is used, which is provided by LANL. The data that contains the filters and repair time is more than 20 different systems collected from 1996 to 2005. When analyzing computer system filters, it's necessary to consider the correlation between the filters and use the larger scale service computer system, the LNL dataset, for analysis. As shown in figure, although there are not much difference in the proportion of the number of fault correlation to the total number of faults, there is a big difference in the time of fault correlation. There are 6 types of filters in the dataset, which are a software, human error, a network, hardware, and automated. Sensitive filter is cast by the environment. By analyzing the correlation between filters, the dependability of the system can be further accurately evaluated. So the analysis of a typical filter in the dataset is shown in the figure. The theorem is used to prove the correlations of the algorithm. Since the real system, the state space is very large. Therefore, it's almost impossible to solve the Poisson equation. Algorithm 2 is used to evaluate the performance potential function. The return value of the fault state is set to 0 and the return value for the normal state is set to 1. We have repeated the simulations 10 times and each state transition is 100,000 times at the path, and the averages is taken. The dynamic process of the performance potential function is shown as in figure. We first regulate the absence of appropriate Jingyu value and then calculate the means and the variance of the deviation from the theoretical value. It's present in Table 1. In order to further evaluate the performance of a algorithm, The air-step algorithm of CTMDV performance potential used use for combination with a logical auxiliary tool. The result obtained by the algorithm and the mean of the series code division are used to evaluate the performance of our algorithm. Now we come to the latter part, the conclusion. In this paper, we establish a dependability model which takes into account the filter coloration, embeds the DTMC, and analyze the attribute of dependability. Moreover, we formulate the dependability optimization problem as a CTMDP and present effective algorithm to solve the problem. Finally, we evaluate our average by simulation experiments based on real-world data sets. In future, we will continue to analyze the data and propose a new model capturing the dynamic of edge computing system and design new measures with high effectivity. That's all for my presentation. Thank you.